Hi! Today we're going to be taking a look at how to sketch the graph of quadratics. So that is of course graphing equations of the form y equals a lots of x squared plus b lots of x plus c, where the a, b and c are constants. I think it's also worth addressing a certain mindset that some students come into this sort of content with, which is they look at graph sketching as a whole as a bit of a chore. They look at it as like, oh, we're doing graph sketching. Oh, why do we have to do this? I want you to change your mindset with that regard when it comes to A-level content, because graph sketching stops really becoming this thing that you're just doing for the sake of it, and instead it becomes something that we start to do optionally because it's something that will help us. We're going to be using it throughout A-level as a tool to help us solve certain problems that, although could technically be done without a graph, are much easier and much quicker, believe it or not, if you do draw the graph of something. So that's something to bear in mind when we're looking at this stuff. But anyway, how do we sketch the graph of a quadratic? What things do we need to know in order to be able to do that? Well, the first thing you need to consider is the shape, because actually all quadratic graphs have a kind of set shape, if you will, roughly. And the thing that mainly decides what that shape is the value of the constant a in the equation, the coefficient of the x squared. You see, if that value of a is a positive number, in other words it's bigger than 0, then the shape of your graph for the quadratic will look something like this. Obviously the position of it might change and it might get more stretched out in some particular way depending on what's going on, but that's the rough idea of the shape of a quadratic if the coefficient of the x squared is positive. But if the coefficient of the x squared term is negative, well, the quadratic shape is going to be upside down. So you're going to, instead of having a U shape, you have a upside down sort of U shape going on. So that's something to bear in mind, because you can instantly tell what sort of thing you should be drawing just by looking at that number in front of the x squared. And the next thing we need to consider is the value of the y-intercept. Where is the y-intercept? I've written y-intercepts, plural there, but in reality for a quadratic it'll only ever be one y-intercept. Something to bear in mind is the way you can find that is you plug in x equals 0 into the graph and find the value of y caused by doing that. But those of you eagle-eyed might start to realize after a while that the value of the plus c in the quadratic equation actually ends up always just being the y-intercept for a quadratic graph. However, when I'm doing this stuff right now, I'm trying to lay the groundwork for just general good ideas for graph sketching as a whole. And something I want you to watch out for is not to just always assume any plus c value for any graph will always be the y-intercept for those graphs. Sure, it works for quadratics, sure, it works for straight lines, but there are some graphs where the constant you see added on the end won't be the y-intercept. And so therefore a more general overview of how to find y-intercepts in general would be this strategy I've said here, which is plug in x equals 0. Then we also need to find x-intercepts, and the way you find x-intercepts is, well, basically kind of similar to y-intercepts, but the x and the y are swapping roles. Now we're going to plug in y equals 0, and then we've got to find the values of x caused by plugging y equals 0. In order to do that for a quadratic, that is going to require you to solve a quadratic equation as part of doing that, but it's still this idea of plugging in the other letter set equal to 0 and then therefore solving the equation to find the letter you want. So with all that said, let's get started. So we can see for this example the coefficient of the x squared is a positive number. It's bigger than 0, and therefore straight away we know the shape of our graph is going to be that U shape that quadratics have. Should be a symmetrical shape. We know the y-intercepts could be found by plugging in x equals 0, or just simply realizing it's going to be the number on the end. For quadratics, that won't always be true for all types of graphs. And then we also know we can find x-intercepts by plugging y equals 0, which will lead to the equation 0 equals 2x squared plus 11x minus 6. Now, of course, that's a quadratic equation to solve, so therefore now it's a bit of a throwback to my video on how to solve quadratics, where I said the first thing I always try and do is factorize if I can see that it's going to be quick and easy to factorize, because factorizing is meant to be the quick option. For this particular one, although it does factorize, funny enough, it's maybe not a type of factorizing that you would just instantly spot just by looking at it, potentially. And therefore, if that's the case for you, then move on to using the quadratic formula. Basically, don't spend ages solving a quadratic equation. It's always meant to be a quick process. So, although I'm mostly going to be using the calculator when solving a quadratic using the quadratic formula, I still have to write out my working. And the same is true for you, so do remember to do that. So there you go, that is the quadratic formula with the numbers plugged in, crucially. And then we can use the calculator to help us work those out. I'd first plug this in with the minus chosen for the plus minus, and that will get me -6. And then I could also type this stuff in, but instead of the minus for the plus minus on, this time choose the plus. And if I do that, you will end up with +1/2. Nice. So therefore, we now have all the bits of information we need in order to be able to draw the graph. So let's draw some axes. And there you go. We know the y-intercept is going to be -6, so I could mark that on there. We know one x-intercept is at half, the other is at -6. And therefore, we know what we need to draw. We just need to put this U shape imposed on this graph we've got here, making sure it goes through those 3 points I've marked on. So you can draw it. So doing that. There, like that, except you might notice that this has been a terrible drawing, and that isn't a coincidence. See, some students will find it absolutely fine being able to do that. They'll draw their axes, mark on where the x and the y intercepts are, and then are able to draw a curve that's nice and smooth and does go through those 3 points. I'll be honest though, for most people, including me, that's actually quite difficult to do. Because the problem is you're having to deal with lots of objectives all at once. You're trying to concentrate on getting the right shape, but you're also trying to make sure it goes through those particular points in those particular places. And the problem is you can get to a point where you've been curving around, but you've curved around too much, and then you have to do a bit of a course correction, which is kind of what I've done in that sort of area there, and it looks terrible. So, way that some students find useful, and certainly I use when trying to draw a graph, is sometimes I concentrate first of all without any axes, just trying to draw the curve very well. So therefore, here we go, here's me drawing the quadratic curve shape, nice and smoothly, vaguely symmetrical. There you go, it looks a lot better already. By drawing the curve first, I can then separately concentrate on then drawing the axes and then making sure the axes go through the right places. So for instance, I know that there's 2 x-intercepts, so therefore I know my horizontal x-axis must go through my quadratic curve twice, so therefore it must be roughly around there. And then for drawing my y-axis, I know the right-hand x-intercept, because it's a half, is going to be nearer to the y-axis than the other x-intercept, which is -6. So my y-axis is going to be closer to this x-intercept, so therefore that's why I know to draw the y-axis over here. So that's my tip to you for drawing a much neater graph. It's sometimes a good idea to concentrate first on doing the shape and then put the axes on afterwards, rather than putting the axes on, then trying to make the graph fit through those specific points you marked on. Cool, so that's our first example done. On to our second example where we're going to sketch this graph. And so in this second example, we can see by looking at the coefficient of x squared, there's a minus sign in there, which is implying the coefficient's -1, and therefore it's less than 0, and therefore instantly I know the shape is that upside down U shape. I then can find the y-intercept by plugging in x equals 0, but that of course will just get me y equals that number that's on the end, so y equals -21. I can then find the x-intercepts by plugging in y equals 0, and that will mean I have to solve this quadratic, and I can use whatever method you like for solving this quadratic. However, in one of my previous videos on factorizing quadratics, I did point out if the coefficient of the x squared is just a -1, it actually doesn't make it that much more difficult to factorize, because you just could factorize -1 out of the entire quadratic to begin with, and then try and factorize the quadratic that's left inside the brackets. So funny enough, this quadratic factorizes to, well, we want two numbers that multiply together to make 21, but add together to make -10, so therefore that would be -7 and -3. And so therefore we get the solutions x equals 7 and x equals 3. Okay, so those are our two x-intercepts. We now have all the information we need to draw the graph. Just like last time, I'm first going to concentrate on just getting a good curve. And then the x-axis, I can see there's two x-intercepts, so the x-axis must be intersecting the graph twice, so must be maybe roughly around here. And my x-intercepts are 3 and 7. And I know therefore the y-axis has got to be to the left of the 3, because the y-axis always happens at x equals 0. So let's draw that on maybe about here. And then we can mark on our y-intercept. So that's going to be -21. Cool. So that is most of the time all you're going to have to do to be able to sketch a quadratic. Something worth bearing in mind is you're always expected to make sure your shape is nice and smooth, and so avoiding that mistake I made on the previous slide is quite important. It's also worth pointing out they often mark you based on whether you have put the intercepts marked on the axes, so that's why we had to find them and mark the values on, because that actually contributes to marks. Never hurts to also label your axes themselves, so that's also another important point to this stuff. Cool. However, I did mention before there's one extra bit of information you sometimes need to consider, and that's because you can sometimes be asked to sketch a graph that looks like this. And if you start trying to sketch this, you could go about it normally, first of all, because you'd realize, okay, it's a U shape, you'd realize the y-intercept is at, of course, y equals 21, and then you could try and find the x-intercepts. But when you try and find the x-intercepts, you'd realize very quickly that there's no nice way you can factorize that, and if you tried solving it using the quadratic formula, then you'll get no real roots. And you would realize that because as part of solving it using the quadratic formula, the b squared minus 4ac part comes to a negative number, which is important because then it means we can't square root it to get a real number. So therefore there's no real roots, which is a problem because it means there's no x-intercepts. So how are we going to draw it? Well, the thing is we already know roughly what it's going to look like. We know because it's a positive U shape and there's no x-intercepts that it must look something either roughly like this, or it must look something like this. In other words, the vertex, the minimum point, must be above the x-axis somewhere, because if it was below the x-axis, of course that would mean the graph, if it has a U shape as well, it would have to be intersecting the x-axis, which is not the case. So how are we going to know which of these situations is the correct one? Well, this is where you might consider trying to find the coordinates of the vertex. And to do that, all you have to do is use completing the square. And I've shown in another video how you can use completing the square to find the coordinates of vertices in general of quadratics. So let's have a go at doing that. So the first thing I'm going to do with completing the square is I'm going to factorize the 3, the number in front of the x squared, out of the entire quadratic. So that means I'm going to get 3 lots of x squared plus 12 divided by 3 is 4, so I'm going to get 4x. Some teachers only factorize the number in front of the x squared out of the first 2 terms. As I said in my completing the square video, I factorize out of all 3 terms, because although that means sometimes this third term ends up being a horrible fraction inside the brackets, that doesn't put me off, because I always know I'm going to have a calculator when doing this stuff, so having a fraction involved is not a reason to be put off doing something. And then what we're going to do is look at the number in front of the x, halve it, and put it inside some brackets with an x, all squared, and then immediately take away that number, all squared. And then we haven't done anything with that plus 7, so it remains there. Then we are going to do 7 minus 2 squared, which is plus 3. Then after that, we can then multiply out the big brackets again at the end. Basically, I'm doing that very first step I did, and that will lead to this. And then that tells me the coordinates of the vertex is -2, because although it's a +2 inside the brackets, a reminder that it's always the opposite of what you see inside the brackets with the x, for the x value of the vertex. And then the y coordinate of the vertex is always just that number over there. Worth pointing out, the number that's in front, the a value effectively, has no effect on the vertex at all, as long as you've fully finished the completing the square stuff. By, for instance, the last step I'd do was multiply that 3 by the +3 I had inside the brackets before. Cool, so therefore I now have all the information I need to be able to draw the graph. Because I know, as I said before, it's a U shape, and I know that the vertex is at an x coordinate -2, so it's to the left of the y-axis, and y coordinate is 9, so that means it's above the x-axis as we mentioned before. So I'm going to mark those coordinates on there because that then makes it clear. And then of course we've got that y-intercept of 21 that we said on the previous screen. Cool. Nice. So therefore that will do us for this video. Hopefully you found this video useful. That is how you draw quadratics. However, a lot of the skills we talked about today are ones that will be useful when drawing other graphs as well. I'm always trying to teach you skills that are transferable across many topics in maths, rather than just going, in this very specific scenario, this is the very specific thing you have to do. If we have general skills that work for multiple different scenarios, that's always helpful. Okay, goodbye.